Okay, folks, good afternoon. This is Juergen from CSAT again. Last week, I attended the Zika, the first international conference on Zika virus, and so it was a 3-day conference. I attended 2 days. It was about Zika, epidemiology, pathogenesis, vaccinology, clinical picture, and the vector, which is Aedes, a mosquito called Aedes aegypti. And so it was a very well attended conference in Washington, D.C., about 250 people, and organized by some people actually from Israel. And the common knowledge about Zika is epidemiology was the first session. You know, there are several lineages, African and Asian, and the Asian one went over the Pacific, some islands in Micronesia, Yap Island, and they had outbreaks in several years ago. And then, for whatever reason, it was introduced to Brazil, and it was recognized first because suddenly there were babies born with microcephalus. Small brains, etc., and there were some other deformations, and so people got very concerned, and then they realized this virus, Zika virus, which is a flavivirus transmitted by vectors, is most likely the cause of it. And then it went to other countries in South America, especially Colombia is very hard hit in the Cali region, and then even into Florida. And so it caused a big concern, obviously, for public health, and that's why people discussed it. And so people came from Asia, Africa, and from these Micronesia islands and discussed the epidemiology of it. And then there was a lot of discussion on diagnostics because there is cross-reactivity with other flaviviruses, and that was a big issue in the beginning to diagnose it, and now they're figuring out specific tests for Zika, and we can differentiate it from other flaviviruses, which are important in our in North and South America. And I chaired a session on on virology, and the first talk was by a guy who really discussed all these congenital infections with various viruses, including Zika, like cytomegalovirus, HIV, and other viruses which affect mother and the baby. And there are very common pathogenicity pictures, very common features to all these infections, how the virus crosses the placenta and goes into the fetal tissues and causes damage there. There are common features to that. And then there were some really nice talks on. They already have the crystal structures of some of the proteins which are critical for that virus, and they use these crystal structures of the some of the NS non-structural protein, I think 2B and NS3, to design novel antiviral drugs, because that's the next thing before a vaccine is available. And so this is actually a very beautiful work from Germany and from China, which was presented there, crystal structures of several non-structural proteins and how this crystal structure can be used especially to block the enzymatic area of the protein with antiviral peptides or antiviral compounds to really block virus replication and the effect of the virus on the mother and the child. And so that was a very actually exciting data they presented. And then they also talked on new vaccines, which work pretty well in the animal models. Obviously, it takes years before a new vaccine will be approved by the FDA, the Food and Drug Administration. But there are several efforts from various groups around this country and other countries to produce efficacious vaccines for Zika virus infections. And then they discussed also in detail the mosquito component. and why and how these mosquitoes carry that virus, and what is the origin, how these mosquitoes dispersed over the world, and how they are now moving with the climate changes within North America, Europe, etc. One important question I was asked is how does affect Zika virus animal health? And there is no evidence so far that Zika is infecting livestock in this country or any wildlife. We know that Zika virus infects non-human primates, so if we have an endemic area and we have a zoo, it could well be that Zika could infect some of the macaques, the rhesus monkeys in zoos. There have been experimental studies by two groups, one Canadian and one American group, to infect pigs, for example, and newborn or very young pigs are really susceptible to the infection and replicate the virus, so there might also be an issue if feral pigs are susceptible. And then there was a big study done by Dick Bowen at Colorado State, which infect the whole array of animals, and they found virus replication only in frogs, yes, in amphibia, and in the armadillo. And what that means, I do not know. That was experimental infection. They found virus antibodies, antiviral antibodies in pigs and rabbits and other animals, but no virus replication in these animals. So the question is still open, what role animals, even amphibia, will play if this virus becomes endemic in North America. Thank you very much.